The mission of the Air Force Systems Command is to research, develop, test, evaluate, procure, and produce new materials and systems in support of aerospace power. Systems must be of superior quality, yet be affordable and maintainable, and above all, more than equal to the systems of a potential enemy. The A-10 is the first Air Force aircraft to be developed specifically for the close air support role in a combat zone. It can loiter in a combat area for almost 2 hours and still return to a base 250 miles away. The A-10 can operate on 2,000-foot runways close to the battle area to improve its response to combat conditions. It's also designed for rapid turnaround between missions and sustained operations over a long period of time. Its cruising speed is 340 miles per hour for low altitude and low airspeed operations, where faster aircraft are less effective. This twin-engine single-seat aircraft can carry up to 8 tons of mixed ordnance, including conventional bombs, rockets, and air-to-surface missiles. Its unique armament, however, is the 30-millimeter Gatling gun, which can fire 2,000 or 4,000 rounds per minute. This gun can defeat heavily armored tanks in a single strafing pass. For survivability, the A-10 combines a backup flight control system and self-sealing fuel tanks with protective armor enclosing the cockpit area. The armor protects the pilot from both high explosives and 23-millimeter armor-piercing projectiles. The A-10 has advanced avionics, including a head-up display unit, which couples a visual presentation of both combat and flight information with target identification and fire control equipment. The Tactical Air Command received the first A-10 in March of 1976, and eventually, over 700 aircraft will be in service. Cobra Dane is a large radar system on Shemya Island, one of the most remote points in the Aleutian Island chain. This phased array radar is 100 feet high and 96 feet across. Its face contains 34,000 elements that can transmit and receive signals. Primarily, this radar gathers intelligence information from Soviet ballistic missile flights. In addition, it provides object warning and tracking in the event of a general missile attack. The Cobra Dane system is operated by the Aerospace Defense Command. The GBU-15 is a modular glide weapon. The planar wing version is launched from high altitudes, and the cruciform wing weapon from low altitudes. The baseline kit, common to both configurations, includes the control module, warhead adapter, and television guidance module. Munitions carried on both include the Mark 84 2,000-pound general-purpose bomb and the Su-54 dispenser for cluster munitions. Guidance options include TV data link, imaging infrared, and distance measuring equipment. The planar wing version is effective for high-altitude, long-range attack. The B-52 launches the weapon, initiates mid-course corrections, and directs it into a target with extreme accuracy. For low-level short-range attack, the cruciform wing weapon is launched from fighter aircraft. This design is highly maneuverable for mid-course corrections at close range, improving accuracy against ground targets. At low altitudes, the TV guidance system is effective against targets such as missile sites, ground vehicles, and ships. Further development will produce a family of modular glide weapons for use in high-threat areas. While the Minuteman program has been continually improved to increase range, accuracy, and reliability, the Air Force is concerned about improving the survivability of the land-based ICBM force. To fulfill future ICBM requirements, the Air Force has initiated the MX program. 2 major tasks are underway: the study and selection of multiple aim point basing options and the definition of a new and larger ICBM. Several mobile basing options have been selected for more detailed evaluation: the shelter system and the trench system. The trench concept includes a network of underground trenches that would provide no specific aim point data for enemy missiles. The trench would be strong enough to resist blast pressures, yet still allow breakout for missile launches from unmanned vehicles. The shelter concept involves a random switching of missiles between hardened shelters on mobile transport systems. It would force an enemy to execute a complex and difficult attack to destroy each sheltered missile. A third concept involves missiles moved at random, denying a specific aim point for enemy missiles. This is sometimes called the shell game concept. The missile design itself would result in larger payloads, improved efficiency, and increased accuracy over the Minuteman III. Current hardware validation is in progress to reduce technological risks and provide reliable development cost estimates. The F-16 is a lightweight fighter aircraft designed to complement the more sophisticated F-15 in the air superiority role and supplement other aircraft in the ground support role. It combines proven system components with advanced engineering technology to achieve a modern yet low-cost fighter aircraft. Non-metallic materials are used in certain structures to decrease weight. Borrowed from the space program, a fly-by-wire flight control system improves flight performance and contributes to maneuverability. A 30-degree reclined cockpit seat reduces the effect of high G-forces on the pilot. Automatically variable wing leading edges are used to improve lift, directional stability, and buffet characteristics. Other features include a control stick located at one side and a single-piece bubble canopy, giving the pilot much better visibility from the cockpit. The F-16's weapons include a 20-millimeter multi-barrel cannon and heat-seeking missiles mounted on each wingtip. Both are coupled to a head-up display unit, which shows flight information as well as combat information for acquisition and tracking of air and ground targets. 5 tons of various air-to-ground weapons can be carried on wing stations. The F-16 uses the same advanced technology engine as the F-15. This simplifies logistics, and it's more cost-effective. This improved engine produces more power per pound of engine weight than the best previous fighter engine. It allows a maximum speed of over Mach 2 and a radius of action of over 500 miles. The F-16 was selected by several NATO countries for their air forces. Through a multinational consortium, these countries and the United States will co-produce the F-16s to be used by them. Combining advanced aeronautical designs and proven electronic components, the F-16 offers a high-performance and cost-effective addition to the tactical fighter force. The Navstar Global Positioning System will be a worldwide network of satellites transmitting precise, jam-resistant navigational signals. These signals could be deciphered by special receivers to determine longitude, latitude, altitude, speed, and time. 24 satellites will orbit the Earth every 12 hours to provide highly accurate and continuous global coverage to the Army, Marines, Air Force, and the Navy. With this system, a ship could determine its precise position on any ocean in the world within 30 feet. A tank unit could accurately determine local time for a coordinated attack. Additional applications include precise weapons delivery during inclement weather, improved approaches and poor visibility, accurate aerial refueling rendezvous, and more efficient search and rescue operations. Monitor stations around the world would continually gather the satellite signals. During the 1980s, the Navstar system will provide an accurate, cost-effective global positioning capability. The E-4 provides the National Command Authority and Strategic Air Command with a highly survivable airborne command post to replace the EC-135. The E-4, with its advanced equipment, offers more effective supervision of strategic forces during a general war. It includes many improved features, such as nuclear hardening, an advanced technical control facility, satellite communications equipment, and a larger battle staff capacity. Able to carry nearly 3 times the equipment of the EC-135, the E-4 also has an increased flight endurance of 12 hours. This could be further extended by air-to-air refueling. The E-4s serve as National Emergency Airborne Command Posts. The Air Force was selected as the executive agent for the Department of Defense in all NASA Space Transportation System activities. This includes a space shuttle vehicle to be launched into orbit for space missions during the 1980s and beyond. The Air Force is developing the Inertial Upper Stage Propulsion System, the Inertial Upper Stage Launch Support Facilities at the Eastern Test Range in Florida, and preparing launch and recovery facilities at Vandenberg Air Force Base, California. Based on NASA estimates, the Air Force projects overall cost reductions for DoD space missions while improving future operational capabilities. The space shuttle will deliver greater payloads at a lower cost per flight than present launch systems. After delivering satellites to orbiting positions, the shuttle could make maintenance visits and eventually retrieve satellites, returning to Earth with up to 16 tons of payload. As part of the testing program, the shuttle was mated to a 747 for tests evaluating the vehicle's flight characteristics. After its mission, the shuttle will glide back and land on a 15,000-foot runway, much like conventional aircraft. It could perform more than 100 missions during its lifespan. The shuttle will become a valuable asset for NASA space operations and the Department of Defense. A modified 707 is the basis for the E-3A, Airborne Warning and Control System. It serves as a command and control center in both tactical and air defense roles. The E-3A's sophisticated electronic equipment can detect, identify, and monitor the interception of opposing forces during a conventional war. Its unique radar looks down on a large geographic area from 30,000 feet and detects targets without losing them in ground clutter. At more than 200 miles, the E-3A can spot fighters at low altitudes, regardless of terrain or weather. The E-3A incorporates a tactical air control system to monitor and direct encounters with enemy aircraft. Computer display screens indicate detailed information on the progress of all aircraft to provide the mission controllers with a display of battle conditions. More flexible than land-based radars, the E-3A greatly improves the capability to manage an airspace. The F-15 is a new advanced fighter aircraft capable of gaining and maintaining air superiority against enemy fighters in all types of aerial combat. It's designed specifically to secure the airspace over a battle area, to allow tactical missions to operate without threat of an air attack. The F-15 is the first U.S. fighter aircraft whose engines produce thrust greater than the weight of the loaded aircraft. It has even exceeded the speed of sound in a vertical climb. These engines, together with an efficient wing design, allow the F-15 to maneuver very tightly without losing airspeed. This is critical in a medium or low altitude encounter with enemy aircraft. This twin-engine fighter has a fuel capacity for a wide combat radius and can use a variety of aerial weapons. The F-15 has been tested against a modified F-5E to compare its combat capability with existing fighters. The F-15 consistently maintained a combat advantage. The sophisticated avionics systems in the F-15 greatly enhance its combat effectiveness. Its versatile radar permits target detection and tracking from point-blank range to beyond visual contact. It can also distinguish targets below the aircraft in spite of ground clutter. The head-up display unit shows separate information for each weapon system, as well as flight information to assist the pilot during combat. Against aircraft like the F-4, the F-15 has achieved an overwhelming win record during combat maneuvering tests. The F-15 can use all the classical maneuvers and use them in a greater variety of situations than any previous aircraft. The F-15's outstanding performance in all types of weather, day or night, during complex combat conditions, enhances U.S. air superiority into the 1980s and beyond. These are some of the highlights of the Air Force Systems Command research, development, test, evaluation, procurement, and production. Only through vigorous and progressive programs can we maintain the edge in aerospace power.
Boy, you better be paying attention.
That's the tower.
Oh.
That's funny.
Maybe I woke somebody up.
That's funny.
Yeah, I remember now. Not until we get out there.
Yeah.
Yeah, I'm bad.
And I got a quick last minute check the brakes there. That was good that they held for me. Alright, there you go. Off to the races.
Here we go.
All right. Wow.
Here we go.
Set. Power's coming in. Good engine. Brake release. Full power. And the good engine airspeed is alive. A little bit of gusts coming in. Full control down the runway. 70, rotate. And gear is coming up. Alright, gear up.
Very cool.
Yeah, we're flying, dude. Now we gotta go catch your uncle there. What was his name again?
Greg.
Greg?
Yes.
So Greg and Chris.
So is it possible it could get bumpy enough where I hit my head up here?
This happened.
Alright.
Well, there'll be none of that today. As long as you stay below them and to the right, there will be none of that.
Awesome.
Alright, well, hey, dude. It's that time of the flight. You ready to take over?
Oh, of course.
Alright, right hand on the stick.
Yep.
And nice and easy, you have the controls.
Awesome.
Look at that, dude. You're flying.
Almost afraid to fly it.
Here, take the stick.
Alright. Yeah.
There's Knott's Berry Farm.
How do I know? Huh?
Knott's Berry Farm right down there.
Alright.
It's a beautiful day in the neighborhood.
Oh, yeah. I guess Greg is flying as well because he's going all over the place.
Who knows? It could be either of them at this point. I really don't know. Alright, let's stay below them.
Yep.
That nose always supposed to be up like that?
On a climb, yes.
Wow, this is gonna be weird.
Not bad. So far, so good. Usually, in the first 30 seconds, everyone's all over the place, so it's pretty good that you're at least in the hemisphere.
Yeah.
Alright, it's climbing, so pull back on the stick some. Not too much, coming a little bit to the left. And then when you kind of left, you're going to have to eventually correct back to the right to stop your travel towards him.
Yep.
Actually, I can kind of tell you have some of that sim time because you have a better finite control of the stick than most people do. Good job. It's a good start.
Well, thanks.
And Smudge Trojan, radio check.
Yeah, loud and clear.
Roger that, just want to check, I had my volume all the way down, so I wasn't sure if you were calling me or not. Nope.
Air combat at 2,700.
Get it all. Hopefully I can fight through this, buddy. As long as everything, you tell me everything's gonna be alright.
Everything's gonna be alright. Hey, the practice area frequency is 121.95, right? Affirmative. Okay.
Damn, this is fun.
Oh, yeah. It's like a dream come true.
You're doing fantastic on the formation, by the way. Fantastic.
Oh, thank you.
This is really good. Hey, if it's okay with you, we're going to go ahead and slide back. That way you can get a little bit of tracking time before we start the exercise.
Yep.
Roger. Roger, sliding back. Alright, here's the next thing we're going to do. Gun sight's coming on.
Yep.
I want you to basically let him kind of slide in front of you. You might feel some of its wake turbulence right now, so no worries if that happens.
Yep. Oh, yeah.
Yeah, there it is. Okay, go ahead and you have your gun sight on. You can see him, right?
Yep.
Alright, go ahead and put that gun sight right on him. Let me know when you have it on him.
I'm on him.
And we're in a nice trail position whenever you'd like your clear to maneuver.
Hey, here we go.
Oh, some of that wash.
Yeah, remember traffic, 11 o'clock, opposite direction, -800, about a mile.
Oh, have him in sight.